The fundamental counting principles are using statistics to determine the different combinations that can be obtained in different situations and depending the given options that we have in each problem. Basically, we have two basic principles in the counting process. The first one, and basically the easiest one to analyze, is the multiplication principle. And the second one is the addition principle. In the next examples, we're going to analyze the multiplication principle and its application. As you can see in here, the multiplication principle for counting states the following. If one selection can be made in n ways, and for each of these a second selection can be made in n ways, then the number of ways the two selections can be made is the product of m and n. In other words, let's see the first example. Elena can wear one of 2 blouses and one of 5 scarves. How many blouse scarf combinations are available to her? If we can, we're going to make a diagram, okay? Now, the possibilities for creating a diagram are the following, okay? We can have a diagram that is called the branch diagram, okay? And in here, we're going to choose, for example, we're going to identify blouse 1, and we're going to combine it with a scarf number 1, a scarf number 2, a scarf number 3, scarf number 4, and scarf number 5. And we can do exactly the same thing with blouse number 2. We combine, this is blouse with scarf number 1, with a scarf number 2, with a scarf number 3, with a scarf number 4, and with scarf number 5. So this is what we call the branch diagram, okay? This is a branch diagram. Why do we call it branch? Because if you see, it opens like the branches of the tree, okay? Now, if we want to make a list of the possible combinations, then I can do this. B1 is 1 for the first combination, then B1 is 2, B1 is 3, B1 is 4, and B1 is 5. We do the same for the second blouse. B2 is 1, B2 is 2, B3 is 3, B2 is 3, B2 is 4, and finally B2 and is 5. This is what we know as the list of combinations, okay? The list of possible combinations. Hey, in this case, the list of combinations and the branch diagram are basically short issues, okay? So, but when we have, for example, 10 blouses and 20 scarves, this will be a bigger diagram and this will be a bigger list. Therefore, what we do is we directly identify that M will be the number of blouses that are going to be analyzed. N will be the number of scarves that are going to be chosen. And basically what we do is multiply M times N directly. So 2 times 5, and the answer will be 10 possible combinations. Okay, or 10 possibilities if you want to see it that way. And so it is very easy to use, okay, either the branch diagram, the list of combinations, or directly if we use the principle M times N. Okay? These are 3 possibilities that you can have. Now, depending on the amounts and the number of options that we have, then it is possible that this branch diagram can be done, or that list of combinations can be presented like this. When numbers are very big, then what we do is we directly go into the property m times n, and we apply it. Let's analyze these other two problems. Right? It says in here that George can choose among 15 flavors of ice cream, 6 different flavors of popsicles, and 5 different flavors of frozen yogurt. In how many ways can he choose a single dessert? So, as I was telling you before, depending on the amounts that we're going to manage in here, what we're going to do in this case is we're going to analyze directly the application of the principle. M will stand for the ice cream. N will represent the popsicles that we are going to choose. And since we have a third option, then we include letter P. And in this case, we use P to represent the frozen yogurt. Okay, so what you do is you analyze the principle. Since the numbers are very big, okay, we are going to apply directly the property. M times N times P. In this case, 15, that multiplies 6, that multiplies 5. So at the end, your final answer will be 450 ways to choose one dessert. Okay, so if you analyze, if we try to create a branch diagram for this option, maybe we can do it for one flavor of ice cream and the flavors of popsicles and the flavor of frozen yogurt. But if we start creating all the possible combinations, it will end up being a very big branch diagram. Okay, let's analyze what happens in example number 3, similar to the same one, to this one that we had before. It says in here that Ray can choose among 10 horror novels, 5 different action novels, and 6 poetry books. In how many ways can he make a combination of horror, action, poetry book? So we use the same criteria. M will represent horror novels. Okay, the horror novels. N is going to represent the action novels. And P is going to represent, in this case, the poetry books. Right? If you want to use different variables, you are free to use them, okay? As long as you respect the principle that is multiplication. So if we apply the principle in here, it will be M times N times P. So in this case, we're going to have 10, which represents the horror novels, 5, that represents the action books, and 6, that represents the poetry books. Finally, the complete answer for this will be 300 combinations of books. Oh, these are examples of the application of the multiplication principle for the counting process.